Welcome to another 3D printing news Unpeeled. Today, we're looking at hydrogels for buildings, kind of a surprising one there. An MIT invention of a solenoid that's made using a quite accessible 3D printer, and maybe rocket engines being made for the Pentagon. So let's start with the first article. The first story is by Malgorzata Zboinska, who, with a team of people at Chalmers University and the Wallenberg Wood Science Center, has developed a hydrogel that they hope will be used for building panels. So they made a hydrogel. Well, a hydrogel is, of course, used a lot in bioprinting, other kind of medical applications. It shows a lot of promise. It's a really exciting material to print into as a support material, or to act as a printing material itself. And now what they've done is they've put a nano-cellulose material together with alginate and made this a hydrogel that they've managed to extrude in a kind of coherent way. And now they're making kind of like A4 size, relatively flat kind of things out of it. Now, what they hope to do with this thing is make panels and building panels, maybe acoustic panels, maybe even kind of room dividers and things like that. Any kind of lightweight type structures. So they're not really going to build like a house out of this, but a lot of panels you might find in your kitchen and other rooms and stuff like that. And that would mean that it's a very, very environmentally friendly material indeed. Of course, now to get into code, they might have to add in some fire retardant. We don't know how much this costs, and we don't know if it could be scaled up. But I like this idea. We're always talking about 3D printing construction being environmentally friendly. Well, of course, if you're using concrete, which is terrible material, very wasteful in terms of the environment, and you're going to then use less concrete, then yes, it's more environmentally friendly. But if we were to truly revolutionize construction, we would replace concrete with something much, much more sustainable, a waste material that's elsewhere, a biological material, something that can be recycled, or something that's a combination of all three of those things. So that would be something that we really would be hoping to see in the future. So this is a good development. It's nice to see that people are working on this kind of thing. This comes to us via Euro News, and they have a website with a movie showcasing an interview with the research and also how this printing process works. It's an extrusion process. Now, there's another story that comes to us via Reuters, and it feels like a lot like a kind of leaked story, to be honest. But essentially, the rumor has it that a major Pentagon rocket contract is not going to go to one of the major established players in rocket motors, but actually to a startup, and one of those might be Ursa Major. Or it could be Firehawk Aerospace. A major Pentagon official said recently that she was going to go to a privately owned rocket motor startup and attend them, and was really excited about giving them work. She said that they were using 3D printing to print solid rocket motors. Now, there's two major companies doing this. Firehawk is doing this, and Ursa Major is doing this. The Reuters article seems to imply that Ursa Major is going to get the contract. We don't know yet if anyone's going to get a contract, but it is encouraging to see that the Pentagon is looking for ways to go beyond the constrained supply of other rocket engine companies who are working with really age-old technologies and really old manufacturing techniques, very slow manufacturing techniques, and working to a way where they could go to automated manufacturing techniques. It can be much quicker in the way of actually replenishing rocket supplies. This is, of course, currently, because of the war in Ukraine, a big issue, but also, of course, in future Pentagon thinking, the Pentagon's going to think, wait a minute, if we need 1,000 of these things at one point, and the guy's telling us that we can make one every 3 months, that's not going to work for us. So they really are actively looking at exploring different things, trying to shake up the old system, and that can be very good for 3D printing industry as a whole. Now, we must note, again, I've mentioned this before, that currently the Air Force Research Lab, the Navy, the Department of Defense generally is becoming the biggest single funding mechanism for 3D printing. So bigger than VC, P&E investments, other kind of SPAC type investments. Right now, it's a U.S. government that has been the single biggest source of funding, the money going into 3D printing at this present moment. Now, that is good for certain parts of the industry, could really develop our industry, but also will militarize it, and also will kind of split up our industry, including to people, into people that can get those contracts, usually American companies, and other people that definitely will not get these contracts, think Chinese companies, and kind of people in the middle, think a French company that maybe would be able to do some work, but not everything. So this is going to have some fundamental medium-term changes and impacts of the 3D printing industry. And if there's a dearth of private funding for a number of months or years, it may very well, last for these profound impacts may very well last for a very long time. So we should realize that. And there's also then the ethical concerns of what happens if we militarize our technology, or what happens if we're primarily a military technology. So that's something we should always be conscious of. The next thing is also has a lot of military application, by the way, because militaries world over are trying to print magnetic materials and things for to power and do the controls of rockets and all sorts of other vehicles. So this could be very interesting for those people as well. This is a report from MIT that a research team has used an E3D motion system ToolChanger. You may remember that. That's a really accessible 3D printer. And I remember that it was killed off in 2022 or something like that. I don't remember when it was brought on the market. It was like the kitchen sink at the time, and it was really, really wonderful to see a tool changing machine on the market from the guys from E3D. It was really, really great experimental machine for a lot of people. I think I'm not the only one that was sad that it was discontinued. But now it's been used for this research by Jorge Cañada, Hyeonseok Kim, and Velásquez-García. They've heavily modified actually, this E3D system to print dialectic and conductive structures. They've made a solenoid, and that solenoid apparently is very efficient. It's very, very efficient in terms of the mass it occupies. It could be made conformal. And what I love about this is, okay, they use this E3D system, not available right now, but it's a, not some super mega high tech, some super really expensive system. It's a very accessible system. And they're using like 3D Fuel Pro PLA Plus, right? They're using a Protoplant, has an iron-filled metal PLA. They're using that. And they're using a copper dope PLA filament from Electrifi. So they've made this with a printer that you could buy, and they're with filaments that you could buy. And actually, you could do this as well. So that means that the home level experimentation of this, and also like think of other universities who want to replicate this experiment, make their own solenoid designs. This is something they could quite easily do with a kind of extrusion system and some off the shelf filaments that could make a lot of sense for them to do. And going forward, if you'd like to manufacture this stuff in small production runs, well, it's quite easily done by just buying a bunch of these systems and a bunch of PLA and keep making it. Now, of course, if we're truly going to make an actual manufacturing solution, like millions of parts, a lot of stuff is going to change. But a lot of people reported the story of 3D printed solenoids and magnetic components. Yes, that's important, but that's been done before. But what I specifically like a lot about this is it's using accessible filaments that have been developed for people to make these materials and to make advanced structures. And it's also at the same time using a quite accessible printer, even though you can't buy it off the shelf right now. And I think it's really absolutely wonderful news in that sense of saying, hey guys, there is a lot of stuff that 3D printer at your research station can do that really could have a really, really big impact. So I think that's really good news. Anyway, my name is Joris Peels. This is brought to you by 3dprint.com. I hope you found this